Problem 11, derivatives. So this is a great moment for you because you are now officially calculus. And I'm only going to show you a sneak peek of calculus because I want you to see how easy it is. So after we've developed the idea of how we can use a limit to define the slope, I want to let you know that the slope is a derivative, and it always has been since Algebra 1, since middle school. Whenever we talked about rise over run, that was a derivative. Okay, rise over run is a watered down idea of what a derivative really is. Okay, those of you that took physics, this is the same idea of when we talk about delta, right? When we have, like, for example, delta x over delta t, that's a derivative. That was a slope. Okay, so no big surprises. We get to a point now where everything is 1. Okay, now I wanted to show you a faster way to do these problems without all the limits. Okay, this is the idea of finding a derivative of a function. So this idea is, if we give you a function and it's got a variable to a certain power, then if you want the f prime, right, f prime is the derivative, then you go ahead and take this power, drop it in front, and then minus the power by 1. Okay, this looks very fancy, and it has a lot of important implications, but it isn't really that fancy. Okay. By the way, another way we write f prime, you will see in a lot of books, will be derivative. So the derivative notation with the d, so dx, let's say of f of x. Okay. So let's show you what this means. Okay. So for example, with a, I'm going to show everything in terms of powers, because what we showed you over here on the side is called a power rule. Okay, it's like the #1 derivative rule. Okay, so for example, the function 3x plus 2, I'm going to rewrite this as 3x to the 1 plus 2 times x to the 0. And I'm only showing that because I want to show you that I want to put everything in terms of this, right? X to a power, x to a power. And what this is saying is the following. If we do the power rule, that means a 1 goes in front, and I subtract this power by 1. That means the 0 goes in front, and I subtract this by 1. So essentially what I'm saying is this should be 1 times 3 times x to the 1 minus 1, which is 0, plus 2 times 0 times x to the -1. But let's be honest and not be silly, because x to the 0 power is 1. And 1 times 3 times 1 is 3. And then 2 times 0 is 0. And 0 over anything is going to be 0. So the answer that we get is 3. So the answer to A is simply 3. You don't have to do this algebra all the time. You're going to get to a point where you just see it, and you're able to just go ahead and pump out the derivative very quickly. Okay? You could do the same thing that we're doing right now to problems from before. Oops. And you would see that we get the same answers. For example, for B, which we didn't do, we did the same idea, right? This has a power of 1. If I drop the 1 in front, and I do 1 minus 1, well, this is x to the 0, which is just 1. And then over here we have, well, you saw what happened before, right? The 0 comes out, this disappears, so you get an answer of 4 at the end. Okay. Let's do some more of these, but in more detail. So let's do B. If I do B, this is x to the 1 minus 5 times x to the 0. And again, you don't have to do all these extra variables with extra exponents if you don't need to. I just want to show you what's going on. So we drop this power in front. We subtract this power by 1. 1 minus 1 is 0. Same here. We drop this power in front, and then we subtract it by 1. But again, anything to the 0 power is 1. This is gonna be a recurring theme here. And then anytime, and then over here we have anything times 0 is 0. So the answer to this problem is just 1. Okay. If it helps, let me do that problem again, but in a faster way. Okay. I know that if I take a derivative, if there's a number by itself with no variable, it's gone. Okay. And to be honest, if there's a variable by itself, it's going to be the number in front. Right? So for example, I know that this is going to end up multiplying by 0 at the end and it's gone, and this is going to end up being to the 0 power, so that'll be 1. So my answer to this problem is 1. We saw the same thing with part A, right? If we do the same thing, this is going to end up being gone, and then this ends up being just a coefficient in front, and so the derivative of this is 3. So again, once you're very comfortable with this, it's very easy to do this quickly, okay? And your calculus teachers will expect you to do that. Let's do this one that's a bit more complicated. X squared plus 3 times x to the 1. The power goes in front. We subtract this by 1. So that's actually 2 minus 1. That's the first power. So we have to keep that one. That's not a 0 this time. That's a keeper, okay? And over here, the 1 goes in front. And I subtract this by 1. So that's x to the 0 power. X to the 0 power is 1. Okay? Now don't do the silly thing of adding all this up and saying that the answer is 5x, because it's not 5x. Okay? This ends up being 2x, and this ends up being a 3. So we get 2x plus 3 as the answer for part C. Okay? May I suggest that you, whatever you do, figure it out. Do it the long way, do it the quick way, do it the limit way, whatever you want to try out. But D, try it out, you should get 2x. And E, you should try it out, and you're going to get 4x minus 3. Okay? On that note, I will end with problem 12, and actually make problem 12 your summary, because that's a really good summary. Okay? So try to recap what is a limit. You can be technical if you want. You can, also use words. The more understanding you can demonstrate, the better for you. I don't collect these notes. I don't grade these notes. They're for your understanding and for your improvement and for you to perform well on the test. B, how do we make a prediction, mathematically speaking? And then why do we need limits?